Okay, so the best way to start it is by starting out by filling out what you already know. So you know that right here it's 2 pi or 360 degrees, and right here it is 1/2. Whoa, I can't write. Okay, 1/2 pi, and right here it's 1 pi, and right here it's 1.5 pi, as you may know. So okay, I believe we have all of it done. And next we write the degrees. So this is 90, this is 180, and this is 270. Okay, so once we have that, we start with our coordinates. So starting here, we know that it would be 1 0. Right here it would be um 0 1. Sorry, my brain just blah. And right here would be -1 0, and right here it would be 0 -1. Let me just make sure. Yeah, okay. So now we start with the degrees going that way. So just keep in mind that the degrees are consistent. So you'll start here and go on from there. So right now, like, your starting point would be 0, and right, you would, to begin with, you would add 30, so it'd be 30, and then you would add 15, so that would be 45, and that would be 60. You add 30, which is how you get to 90. Then moving on to this right here, you add 30, so that would be 120, and then right here you add 15, so that would be 135, and then adding 15, 150, and once you add 30, you get 180. Okay, continuing on. I'm sorry if I'm not consistent, like if I write the degrees on the dashed line, like etc. I just printed this one out. It's not definite. So, anywho, right here, so 180 plus 30 is 210, plus 15 is 225, plus 15, 240, and then if you add 30, you get 270. And then right here, if you add 30 once again, you get 300, 315, 330, and of course 360 right there. Okay, so now moving on to the more difficult part. But it's not really that difficult. It's just the whole matter of memorizing it. So right here, a trick that helped me was to remember that all of the numbers with the fractions, they're all going to have similar or the same denominators. So this one would be pi over 6. This one would be pi over 4, and this one would be pi over 3. And one very key detail that can help you go faster is to remember that the ones with the pi over 6 are always closer to the x-axis, and the ones with the pi over 3 are always closer to the y-axis. So remembering that would be easier. So moving onwards, right here you can start by setting up your denominators. So this would be 3, this would be 4, and this would be 6. Okay, so this is the first quadrant, this is the second quadrant. For the second quadrant, it would be very, like, a trick to remember would be that the number next to pi would be one less than the denominator. So for this one, this would be 2 pi, and this one would be 3 pi, and this one would be 5 pi. Let me see if I'm correct. Yes. Okay, so moving on. Right here, it's adding 1 to pi. So using the trick that we talked about, this one, since it's closer to the x-axis, this one would be 6, this one the denominator 4, and this one the denominator of 3. So in this case, you would add 1 to the denominator, so this one would be 7 pi over 6, this one would be 5 pi over 6, and this one would be 4 pi over 3. Okay, and then the trick, it's the same thing, so let's start with the denominators. So in this case, it would be, we would start with 3, and then 4, and then, wait, what happened here? 3, 4, oh, sorry, 4, and then right here, apparently where I put it is the 6. And that makes sense because right next to it is a 360, and that would create a whole if we're going with the whole aspect of fractions. So right here, the trick to remember the numerators is that the following are prime numbers. So 5 pi, 7 pi, and 11 pi. So we finished with that. Now we just need to get our coordinates. So a very easy trick that I memorized was that they're all going to be over 2. So 1, 2, and 3, and they're going to be over 2. So 2, 2. And then the y coordinate, they're going to be 3, 2, 1, and they're also going to be over 2. And all of these have a square root, and it's relentless to put a square root on 1 because square root of 1 is 1. So square root of 3, square root of 3, square root of 3, 3. Okay. And yeah. So, like I said, it's very consistent with the denominators. So, whatever has a denominator of 6 will have this coordinate right here. Same with the denominator of 4, and same with the denominator of 3. So right here, this one would be 1 half 3 over 2. Okay, and in this case, the negative sign would be on the x coordinate, and then it would be 2 over 2, square root of 2, square root of 2. And this one would be, since it's 6, it's 3 over 2, 1 half. I'm sorry it's messy. I'm trying to go along with what I'm writing and with what I'm looking at the camera, and it's very hard. So I'm sorry. And then right here, following the same thing. So since it's a 6, it would start with 3 over 2, and then 1 half. And then in this case, both of them would be negative. Which, if you think about it, is common sense, because if you're going downwards in this direction, it makes sense that they're both negative. Okay, so this would be square root of 2, 2, 3. This one, since it's 3, 1 half, and then 3 over 2. Okay, right here, I'm guessing we're doing this. I'm sorry if you get lost, it's just I got lost with the coordinates that were right here. It was a mess. Okay, so with this one, it would be in this case, following what I said before, only the y coordinate is negative. Then or 2, 2, and then our last one, which is 11 over 6 pi, it's 3, 2, and then so yeah, that's our finished what's it called, unit circle.